Hi guys, Daniele here. Today I want to start a little series about datasets and databases in particular. We will see how to use databases, SQL-lite databases in particular, which is a specific kind of database in Max via Bach and Dada. We will use a lot of data objects for that. So you will need to have the data library installed as well as the Bach one. As I said, this is the first tutorial of a little series, meaning that there will probably be four video tutorials in the first part of the series dedicated to the basic needs, such as how do we construct a database, how do we populate it, how do we retrieve some information, how do we query information, how do we display items graphically, how do we navigate it, and so on. And then there will most likely be an advanced part of the series later on in the future. But let's start with the basics. And the basic question is, why do we even need something more complex than a list to represent data? And in Max, we do have something more complex than a list. We have, for instance, Bach lists. So if a list is not enough, we need a structured list, so Bach lists with levels of hierarchy, for instance. Or you might use some other kind of data in Max. You may or may not be familiar with dictionaries in Max, and if you are, you might want to know that you have two things that will convert from a dictionary to an LLL and vice versa, LLL to dict. So those you can actually retrieve a dictionary from an LLL and vice versa quite easily. So let's suppose you have some data which is properly structured as an LLL, as a Bach Lisp-like linked list, which is just a fancy name to say it's a list with parentheses, where each parenthesis represents a level of hierarchy. In this case, we have a list where we have some names associated with some cities and some IDs. And we might want to know, for instance, given a person, which is his or her city. And I may do that quite easily in Bach. I can click on the message to send it in Bach locate and Bach lookup, so that when I click on Alice, then the address of Alice will be retrieved. So the address of Alice will be 11, but we only need to know that that's the first list we are talking about, so we only take the one but last element. We could have taken the first and it would be the same. And we look up what's in that address, and that will be the whole list: Alice, city, and ID. And we take the city keyword from that list. We expect then to have Atlantic City here, and we do. If you're fine to use bach.eval, then you might want to do that with just one simple line of code, and that's exactly the same thing. And again, this works. So we can have lists structured in this way. We can build them, maybe we can populate them, and then we can search through the list by using bach.locate or bach.find. That's nice. That's fine. The only issue is that bach.locate and bach.find are really searching through the entire list in linear time, meaning that they are really going from one element to the next one, looking if there's some match with the words we are giving in as input. If there's a match, well, that's okay, that they spit it out. If there is not, they go on and then try to find a match. This is called linear time algorithm, meaning that if you have longer and longer lists, it'll take linearly, proportionally longer and longer, I'd say. And this could be fine for short lists. This become unbearable for long lists. For long lists, we have to turn to some dedicated structures where the search is sublinear, where the search is faster than searching element by element. Those structures are usually databases. In particular, in Dada, there's an item called dada.base, which is an implementation of an SQL-lite database. How does it work? Well, a database works by, first of all, we have to give a name to the database. In this case, the name is MyDB. If you have multiple items with the same name, then we refer to the same database. And then we have to fill the database with tables. Ideally, a table is something where you want to put your data in, and if you have different kind of data, you have different kind of tables. For instance, I can have a table for a collection of samples, and I can add it. And I have a table for a collection of scores, and I can add it. And so on. You can add much more tables for collection of people, for collection of towns, and so on. And the syntax for adding the tables has already in itself the structure of the tables. What will the table contain? In this case, my table named sample will contain 1, 2, 3, 4 fields. Those are called fields or columns. And the first field is a file name field, and the S stands for the field type, meaning that it will be a symbol. The second field is called duration. It will be a floating point number. The third field is called centroid. It will be a floating point number. The fourth field will be a skewness named, and it's gonna be a floating point number again. But you can have also integral field with an I, such as nummege, and also list field, which are actually LLL field in general, such as a score. You have to know, though, that the only kinds of data you can query are the integers, floats, and symbols, which are understood by SQLite. SQLite has no concept of lists, so you can retrieve lists in our implementation. So for instance, if I look for a score with a given title, of course I can retrieve the score field, so I can retrieve the list, but I cannot perform queries on that, meaning that I am not able to ask for a score with a specific kind of nodes somewhere. I can of course ask for scores with specific number of measures or specific duration or range of duration and so on. Once we have defined the tables, we need to enter some data. So this is the basic things that we have to do. Create the database, add a table or one or more tables, and add some entries. The entries in a table, which are also called the rows, are input via the add entry message. For instance, add entry samples with a series of fields like file name, duration, centroid, and skewness, which are exactly the fields I had defined in my add table message, adds one entry to the samples table. And the entry is called, will have a file name named my file, a given duration, a given centroid, and a given skewness. And I can do that with more than one entry. And of course, you can imagine you can do that programmatically, not just typing it or using messages. But for the time being, I have added 3 entries in my samples table, so I'm kind of sure I have something in there. I can also double click on database, data.base, and what happens is that the database pops up in LLL form, so I can see what's inside it, and I already see there's one table. This is the first table, which is not empty, because this is the table signature in a sense, which are the columns, and then there's the content, so which are the entries, and we see all the entries we have just put in. And the second table is empty on the other hand. There's just the definition, but there's no entry inside it. This is both a viewer and an editor, meaning that if I want to change something, I can just change it here, and when I close it, the change will be saved and accounted for. I also see that there's one more field I had not put in my definition. The field is called sample ID, and so database has created one more field by itself, which is an ID of the specific entry I'm putting in, and the ID has the same name as the table except for the final S. So in this case it's the singular, sample underscore ID. And that's the underscore ID, of course, at the end. It's good to know that. And when I close this, it means that the centroid for the first one is now 1002. I can see it if I pop it up again, and that's it. This is another example where instead of adding an entry by clicking on a message, we have an algorithm that does it automatically with a score and inserts the entry into our scores table. And what I do is I have to give, if you remember what we put as columns, we put the score we put the title, we put the number of measures, and we put the duration, let's say milliseconds. And so we have to give all those things. If I have a bach.score here, and I want to get all those things, well, the length is just, the duration is just the get length. I can use it with a get length message, and the length will be output here with a length router. So I take the length and I put it here. If I want the number of measures, well, that's kind of the same thing. The number of measures for each voice is output here. If I send get num measures, I retrieve the number of measures, which will have the router num measures, and I'll take the number and I'll put it here. Since I have one voice, it will be just one number, and that'll be okay, an integer. Then I have to know the title, and we can say that the title is containing the first marker of the score. So we can dump the markers then, and we can take the markers here when the markers are dumped, and we'll pick only the second element of the first one. This is actually in the syntax, this is actually the label of the marker, of the first marker. So first marker, second element, meaning it's label. And we'll put it here as title. It's gonna be a symbol probably. And then we dump the body of the score. It's not gonna go here because since it will not find any markers, it will be output here in the null keyword. The null keyword is a special keyword in bach.keys that will output the input only when no other keywords are matched. And this is the score content. We pack them all. Bach.pack is very convenient in this case because it adds the proper level of parentheses for the correct syntax. We prepend the message entry scores in order to give it to MyDB. And when we do that and we click on the message, nothing happens. But if I inspect the database now, we can see that the second table now has one entry titled brother. I could have had some issues because my name was Brother John, so I suppose I have some quotes to be put. We can try to fix that later. The number of measure is correct. The duration is here. It's correct. And that's the score. So that's all the LLLL representing the whole score. And that's kind of it. I could have put, I suppose, quotes in here. And if I do that again, well, it will not overwrite the entry that exists. It will add another one because I have an add entry here. So what I expect is that now the scores has two scores. This is the first one, and here's the second one with name Brother John. And if I want to get rid of the first one, well, I can edit. Of course, I can do that. So I get rid of the first one. I can rename the ID to be 1. And then good to go. And if I want to save it, I can use the write txt message. This is gonna save it in my on my hard drive. This is gonna save it in native mode. This is gonna save it in textual mode. I usually prefer textual mode because I can read it elsewhere easily. This is saving it in a temporary folder on my hard drive. And if I want to read it back because I want to open some other datasets I've used, I can use the read message. What if I want to clear some table, delete all samples in a table? So I can use the clear message. Cleared samples deletes all the samples in the table samples. Clear score deletes all the samples in the table scores. If I want to delete the table itself, I use delete table, which is not just clear. Clear deletes the elements in the table, but not the table. Delete table also deletes the table. And if I want to delete everything, so start from scratch, I use erase. And that's it for today. Those are the basics of how to create a dataset and how to populate it. The next time we will see how to do some analysis. So thanks for staying with me till now and stay tuned.